cells just external to the follicular cells. And these cells form the theca interna. They're epithelial cells. So if FSH is binding to the follicular cells, what would be their equivalent or homologous tissue in the testis? Lady? What binds FSH in the testis? Not Leydig cells. Sertoli cells. No, the Leydig cells bind LH. So the Sertoli cells are homologous to or equivalent to the follicular cells. The Leydig cells are homologous to or equivalent to the theca interna cells. All right? So in the male, these of course are in the female. In the male, these would be the Sertoli cells. In the male, these would be the Leydig cells or interstitial cells. Leydig is shorter to write. So what hormone are they going to have receptors for? Follicular cells bind FSH.
LH.
The theca interna cells bind LH. Now, as we move, there's also fibroblasts and collagen fibers external to the theca interna, and they are identified as the theca externa. I think that's not my sister. Student had a question about the theca interna, so I found this on the internet this morning. So we're not seeing the egg, all right? This would be the follicular cells or granulosa cells. They're epithelial tissue, so they have a basement membrane that you can see here is this purple band. This would be the theca interna, and they're epithelial, so they also have a basement membrane facing of each other. And then out here would be the theca externa.
What?
No, they're connective tissue. The basement, maybe a little bit, but it's not functional. All right. So going back to our follicle development. These cells are secreting estrogen. The follicular cells are secreting estrogen. And that starts to build up and creates puddles of fluid between the follicular cells. The fluid is called a liqueur. You know, you started drinking before you were born, ladies. And as soon as just one of those puddles appears, the follicle is now identified as an antral follicle. Okay? So I'm going to kind of bring our diagramming around in this direction. Remember, this is happening to multiple oocytes. It's not just one of these undergoing this change.
What's this new one called again?
The what?
What's the
I'm
name?
going to draw the antral follicle. So, as soon as one of these spaces appears, it's an antral follicle. The spaces will then join each other as the follicle gets larger and larger until we have just one antrum. Right? We call the largest follicle of that a mature antral follicle. but it's just a matter of degree. There's no other physical change in appearance. So our primary, still a primary oocyte, presence of a zona pellucida. Follicular or granulosa cells, and then some spaces where estrogens and other molecules are in the fluid. Again, it could be one little space or several spaces. As soon as that appears, it is an antral follicle. Yeah. So it has one or more of these spaces an antrum. They start to join together, but as soon as it starts to show a space, it is an antral follicle. All right, to draw the mature antral follicle, I need the whole board.
Hold on.
That's what I'm waiting for.
Oh my gosh. Isn't your little blue scribbles, those are the spaces?
Yes.
Oh, what is that?
These are the space, this is the fluid in the spaces actually. So these are the antrum. This is the reason why we're calling it an antral follicle. Yes.
What was the fluid?
The fluid is estrogen. There's various types, at E2, E1, E3, there's various types of estrogens and some other hormone components of that. But it's rich in estrogens. Yes, JP?
On your follicle number 2, you said there was cuboidal cells around the outside. Do the cuboidal cells not continue to go to where the secondary follicle is?
No, they are. I'm just being lazy.
So there is cuboidal
They're all like that.
Okay, just making sure. I just didn't know if they got changed to
No,
granulosa
not
cells
yet.
or.
They'll change after ovulation.
That's just multiple layers of
Yes.
them?
Okay.
Okay? Ready for me to erase?
Yes.
Go ahead.
So here's the surface of the ovary, all right, with a thin capsule. That would be this area here. And we have a huge antrum. Here is our primary oocyte again. Shortly, it's just about to undergo cell division and form the secondary oocyte, but it hasn't ovulated yet. Has the zona pellucida around it. And this next structure that I was going to draw was always there. I just hadn't identified it as such. But back to those follicular granulosa cells. The single first layer, directly it interacts, has chemical interactions with the zona pellucida. We give a specific name to that layer immediately adjacent to the zona pellucida. And that is known as the corona radiata. And then we continue to have and this is what is released at ovulation. Okay? All those other cells, follicular cells around it are released too, not just the single layer. And so it looks like this. So here would be the secondary oocyte because it's ovulated. The white layer here would be the zona pellucida. And then these would be all the follicular cells, but the immediate adjacent ones would be the corona radiata. Ones immediately adjacent to and interacting with the zona pellucida. Those cells form a stalk that connects it to the wall of the follicle, if you will. And this stalk is known as the egg cloud or cumulus operus. So if you're with somebody that claims to be a weather expert, you start talking about the cumulus operus that you see out in the sky, and they don't correct you, they don't know what they're talking about. And then the rest of the granulosa cells, follicular cells, cells are getting bigger, I'm just being lazy here. Form this huge, mature antral follicle. We would still have the theca interna cells outside it, and the theca externa. That's what these black dots are showing here. Ovulation occurs. Our now divided cell, the secondary oocyte and its first polar body are released as the surface of the egg ruptures. That may, most likely will be, but may or may not be taken up by the oviduct. What's left behind is affected by the hormones and undergoes a reaction so that these follicular granulosa cells and theca interna cells change and form a secretory organ known as the corpus luteum. At first, there's a little bit of bleeding, and so we have the corpus hemorrhagicum. That's just for a few hours. And then it starts to secrete increasing amounts of progesterone and increasing amounts of estrogen as the corpus luteum or yellow body. If pregnancy occurs, if there's fertilization, then this will be maintained by the, you guys have heard of the chorionic gonadotropin, that's the pregnancy hormone that's tested for most commonly. That's made by the cells produced during mitosis of the fertilized egg. That will maintain the corpus luteum for about 3 months until the placenta is ready to do so. If it's not, then about 5 days before menses starts, before the period starts, the corpus luteum decreases rapidly its production of estrogen and progesterone, and then involutes and leaves kind of a scar tissue. It's not really collagen fibers, but kind of a non-functioning structure behind called the white body, known as the corpus albicans.
For albino.
So you have a corpus albicans for every ovulated egg if you're a female. That is the structure present remains in the egg. Yes.
So after it exits the wall and goes out, what happens to the theca interna? Is it
The
all-
theca interna becomes part of that corpus luteum.
So it stays there? So what is it?
It's going to make progesterone. It's
So make
responsible for progesterone. Okay?
That would- no, I was going with that one.
That's where you were going, huh? All right, so let's go through these histology images, and then we'll take a break and come back and look at hormones. Okay?